Hello everyone, my name is Rashna. Today I'm gonna explain lab 4. Uh, I'm going to demonstrate how I wrote a C++ program that retrieves screen information from the frame buffer device on a Linux system. This program uses IOCTL calls to fetch both fixed and variable screen information. It also logs error into file for troubleshooting. Let's go through the code and see it in action. So now I'm gonna go to my lab4 folder. You can see I have two files. One is makefile and another one is lab4.cpp. Here you can see my code I will be running today. It uses the IOCTL system call to communicate with the frame buffer device and fetch screen details. First we open frame buffer device in read only non-blocking mode. Then the user can choose to view either fixed or variable screen information. That's why they use get fixed screen info function. The fixed screen info is retrieved using the FB get fs screen info IOCTL request, while the variable screen info is fetched with the FBIO get v screening info request. We also handle errors by redirecting standard error output to a log called screen.log. This ensures that any issues during execution will be logged. You can see we use get fixed screen info to the top. So let's start by looking at that get fixed screen info function. This function retrieves the fixed function. This function retrieves the uh, fixed screen information such as the visual type, screen accelerator, and capabilities using the FBIO get F screen info IOCTL request. You can see over here, yeah. If there is an error while retrieving this info, the error is captured using str error no and displayed in the log file. You can see on this side. Yeah. Then the next function is get variable screen info, which retrieves the variable screen information such as the X resolution, Y resolution, and bits per pixel using the FBIO get V screening info IOCTL request. Again, if the program encounters any errors, it logs them to the screen.log file. Now we have understood the code. Let's move on to compiling and running it. First, here is the make file we use to compile. It uses G++ to get compile lab4.cpp into an executable, and I can run with the make command. Since we are accessing dev fb0 requires super user privileges, we will run program with sudo to allow it access for the frame buffer device. Once we run the program, we are prompted to choose an option. We can either view the fixed screen information or the variable screen information. Let's choose option 1 to see fixed screen details. So you can see here visual type, accelerator, and capabilities. Now let's select option 2 to view the variable screen information. You can see these X and Y resolutions and bits per pixel. So if there is an error like when running the program without super user privileges, the program will log in the error into the screen.log file. If I run this program without sudo, there will be an error. See, it's permission denied. So I can try to check my screen.log file to check. Here we can see that the program couldn't access because it needs super user privileges. To sum up, we have successfully written a C++ program that retrieves screen information from the frame buffer device using IOTL. We have also implemented error logging to a file for troubleshooting. This is a useful method when working with device drivers in Linux, especially when you need to fetch hardware information. Thank you for watching, and I hope this demonstration was helpful.